All right. Hello, 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 ladies and gentlemen, boys and girls. Welcome to VUX World. I'm your host, as always, Kane Sims, and feel a bit rusty today. We haven't done a podcast for a couple of weeks. Everyone's obviously been on holiday. We've been getting some much-needed rest, although my rest isn't really a rest because I've got two small children and they are absolute tyrants. But we've still been away from it for a little bit, but we are resuming now the VUX program in style with an epic guest today, Vlad Vuskovic of Google. Super experienced fellow Vlad. He was one of the core team that was put together to create Google Assistant. Lots of experience in conversational AI. He's led the product team and product management for conversational AI at Google and is now currently leading the search AI initiatives from a product director of product management perspective. He's got more experience than most people who've probably been on this podcast in the past, and so I'm absolutely delighted to welcome Vlad to VUX World. Vlad, welcome, my friend. How are you? Great. Sorry, I had you on mute there. I've unmuted you now. I sensed you said you were doing well.
Yes. Great. Thank you. Yeah.
Brilliant. Thank you for joining me. Appreciate it. It's been, it's obviously VUX World has been following Google for a long time. We've had a few other people from Google on the podcast in the past, John Bloom. I think we've had Daniel Padgett before. We had actually Anthony Passamard, who was one of the product managers for Contact Center AI a few years ago, and he gave us a good overview of what Contact Center AI is and how it works and all that kind of stuff. At the time, I think there's a few things that weren't quite ready for prime time. The insights bit wasn't quite kind of ready and stuff like that, but it gives us a really good understanding and a good grounding in terms of what it does and the capabilities. And I think that beyond Contact Center AI, which I think we can talk about today, but also Google now from a kind of enterprise tooling perspective has all kinds of capabilities, especially with large language models and generative AI and stuff like that. So I'm really excited to hear your perspectives, your experience, and how you assess where things are at, basically.
Yes, absolutely. Yeah, that sounds great.
Nice. So maybe I mentioned very, very briefly in the intro there, some of your experience. Maybe it'd be nice to hear it from you for the audience. Tell us a little bit about yourself, about your background, about your experience with conversational AI and AI in general, and what kind of led you to Google and what led you to where you are now.
Yeah, great. So I have been working for Google for the past 13 years. I started my career at Google in YouTube, where I was the product manager for several products like YouTube Uploads and other products. And then, my real journey into AI, even though I must say, at Google, like everything touches AI in some way or another, but like my really deep dive into AI happened in 2015, 16, when, I was one of the founders of Google Assistant. And then basically, we tried, we had this big vision of, how to implement the Google Assistant. And, and this is like where we pretty soon realized that, we really need to dig deep into AI to really solve the user problem that we envisioned to solve, right? So basically what our vision, back then was we wanted to have an assistant that would allow you to search conversationally, right? So that was the very first idea, the MVP of the product, so that you can really express what you like to know, and then you would have a conversational experience with Google that would give you the answers, would give you the sources for the answers, and you can also iterate on that, right? So it's actually would understand the context of a conversation. So that was kind of the first product, and then we got even more ambitious. And we said, okay, let it also do more things. Let it do, get things done for you, do actions for you, and so on. So this is like how the whole thing started. And as I said, the real kind of deep dive into AI happened when we started, trying to implement this vision, and then, we wanted to kind of use the existing AI that was there back in times. That was the deep learning applied to natural language processing. It was a recurrent neural network, and LSTMs were kind of the state of the art back then for language processing, understanding. But yeah, like we soon realized that those systems were not able to really solve the product problem in the way that we wanted to implement it, right? So this is how the whole thing started, for me.
Yeah, and so I'm assuming you're alluding there to the NLU technologies and the kind of the way that the intent classification models work and stuff like that, perhaps at the time not really having enough, I suppose, capability or understanding to be able to deal with a lot of the nuances of language, which is very specific long tail stuff that are not the obvious things that you would think of categorizing. Is that what you're getting at?
Yeah, exactly right. So basically, like the way that we ended up kind of implementing the first versions of Assistant was by, and this is like how most of the systems back in time, that actually worked in production at scale with a lot of users. We ended up using, grammars. The so-called grammars is basically like systems, NLP systems implemented by linguists, and that was like extremely, kind of hard to do, extremely expensive. So you basically had to have one of these PhDs in linguistics that at the same time could kind of code at Google level. So extremely hard to find, extremely expensive, and we had to have like one per language. So remember, at a certain time, we had like a team of, I don't know, 50, 60 of linguists, doing implementing this logic to capture, the intent understanding, exactly to your point, right? And then, at the same time, we kind of tried to use deep learning for that, and we had some success with, some classifications, sentiment classifications, some intent classifications as well. But these systems back in times, like recurrent neural networks, LSTMs, they were not good enough. In particular, the problem, two main problems they had that I specifically remember when we tried, like they were not great at learning from a lot of data. So they would forget, things in learning. And then, mathematically, is basically they suffered from this thing that's called vanishing gradients, right? When you're trying to teach them. Then also they were not great in understanding long text. So the context after a bit, kind of got not like really retained well. And then also they were very slow, right? So we could not implement a voice system that would process information almost real time. So those were the problems that we faced, and that actually led us, together to kind of work deeply with the Google research team back then to come up with the next generation of solutions here. Yeah.
And that next generation, is that the generative AI and large language models, or was there something in between what you were doing then with Google Assistant and the large language models and generative AI stuff?
So that's exactly right. So basically, we were one of the teams at Google that had these type of problems, right? So our team, tried to solve these problems, and then there were other teams like Google Translate and Google Search themselves, and and other teams as well. And basically, we all kind of really were pushing the Google research team and working with them to solve this. And this is like where they actually, really overnight almost kind of came up with transformers. Right? That suddenly solved a lot of the problems that these previous systems had, right? So transformers actually, were, solved the problems that I mentioned with RNNs. So basically, they were extremely good at learning from a lot of data, right? To capture the knowledge from a lot of data. They were extremely good at it. And also, the architecture of that model were done in a way that we can actually parallelize it. So we can run it on parallel hardware, and also they would process, differently from RNNs. They would process the sentence, the text in parallel, and not like one word at a time, right? So all of these kind of characteristics really contributed to to suddenly have like a set of tools that we could start ditching our grammars and start really using deep learning to solve natural language, to understand user intent starting with, but then also increasingly to generate. So the generative piece of the transformers, so the decoder who could feedback the everything it generated to kind of generate more. So that was that was really kind of the breakthrough, right? And then the second breakthrough that came also at Google immediately after by the same teams was BERT, right? That used transformers. And the key kind of innovation in BERT was that the research team figured out that usually when you train deep learning models, like usually you would prepare some training set, like you would prepare this is the input and this is desired output, and you would prepare maybe 10,000 20,000 examples like that, and then you would train the model, right? Um, but what the researchers figured out is that since these models could process a lot of text as input and gave text as output, and it also like they like were really fast and worked at huge scales. They figured out that they can actually take any document, right, that exists, like any document on the web or any documents that was available to us, and then just pretend, that they didn't know certain words, but in reality they do know them. So they can basically turn like they figured out they can turn any given document in a training example. And so that allowed them to really kind of start training BERT on like a really substantial part of human knowledge in a way, right? On like a set of Wikipedia or set of like large set of documents and so on, and starting capturing like not only in the linguistics and not only the human language, but also like the world knowledge, common sense in a lot of things, which is really what's sparked in a way the whole generative AI as we know it today.
Interesting. So were you when did you first get your hands on the transformer model kind of stuff then? Because it looks as though you were working on Google Assistant 2016 to 2021. Google Assistant originally was built on recurring neural networks and that type of architecture and technology. In between that, was it 2018 when BERT was released or something like that? 2017.
Yeah, 2017. Yeah, or maybe
Yeah.
early 2018. I forgot the exact date, but yeah, that was like we immediately started using BERT as soon as it came out. So we were engaged, and we immediately started using BERT to do intent recognition, right? So we replaced a lot of the systems that we had in the past with BERT as soon as we could use it across Google Assistant, right? And then starting from there, we increasingly started using more and more of these new technologies.
Right.
Um,
And was there any other benefits that technology gave you beyond intent classification? Because obviously now that we have large language models, generative AI, they're becoming a lot more popular. People are a lot more aware of them. There's all kinds of different use cases people are finding for them. Intent classification seems to be a perfect one because that's a real challenge. Was there any other things at the time that you were using them for or experimenting using them for?
Absolutely, absolutely. There was so increasingly these models proved able to do more and more things. For example, generate answers, like instead of just um, you know kind of classifying that, which is the part that is kind of done by part of the system. But the ability of the kind of the second half of the transformers, the decoders, to actually generate language was also something that we started exploring right away, to use it especially for like more conversational type of interactions with the Google Assistant. And then we started using it increasingly also to kind of recognize what are the actions that the user wants to, but that's maybe kind of goes in the direction of the intent classifications, as you said. And then especially kind of beyond Google Assistant, when I started working in cloud, like this is where these type of large language models like went kind of even more mainstream, to your point, so that we started using them for more and more things, right? Especially in the past few years.
Yeah, absolutely. What led you to Google Cloud then? You were working at Google Assistant for quite a while. You had your hands on a lot of this really great kind of bleeding edge technology. Why did you make the decision to go from the sort of like consumer device kind of category into a more kind of enterprise cloud division?
Oh, that's a really good question. So actually, a lot of the team that ended up working on conversational AI in cloud came, from initially, with me and a few others, came from, like various other parts of Google. And I think that's a great thing because basically, like I was like really enthusiastic about this opportunity to start working, and basically giving to to other enterprises and Google customers the ability to leverage all of these tools that we developed for Google products initially, right? So that was really like an exciting opportunity to kind of start taking all of these systems that that Google Research developed, that we developed, and then kind of packaging them, making them enterprise safe. Keeping innovating on like many aspects. Like that was also something that really excited me back in times, right? Like the ability to do like many new things and innovate on this base technology, and do the applications, try to use them in contact centers. Like that was kind of the first application, because contact centers is really has like a really nice product market fit if you think about it for for this type of technology, because it is really like it presents a set of user problems that are really hard to do. There is a huge value in solving them, and also like you can start solving them with a human in the loop, right? You can start solving them by having a human agent and helping the human agent who is talking to the customer by providing the human agent like a series, basically like the answers, the information needed, and then the human agent can basically kind of make sure that whatever the AI is giving, it's actually relevant and it's true, right? So at the very beginning of kind of using the technology, that was a really nice opportunity, right? So we could actually push the limits because we had a human in the loop, right? Like in real time, who could, who got basically superpowers through AI, but it was a lot less risky, at the beginning. And then after that, basically like we figured out, like for many use cases, the systems that like kind of the chatbots that we were implementing and the voice bots that we were implementing for contact centers were actually, for many use cases, were accurate enough and could actually solve the problems, without like a lot of the need of human agents, but could always escalate to human agents when necessary, right? So it was like I think all in all, like a really nice field where to start employing all of these technologies and kind of get them to the next level in terms of innovation as well. So this is like the reason where I came in along with other kind of leads from and key engineers from other parts of Google to do this type of work.
And I think the other interesting part of that is that when you said that it's a perfect fit, it's like Google Assistant, what's unique about Google Assistant and Amazon Alexa and the voice assistants is that they were the first product categories of their kind that only existed purely to be spoken to. So it was almost like you were creating a new type of customer behavior because you're having to get people to bring in a new device into their home. Then they need to learn how to use it. Of course, one of the benefits of using it is that it's voice, so you should know how to speak, so they're using it a lot easier. But it's still a new mental model about what this device is, what it's capable of, that kind of thing. Whereas in the contact center, there's already conversations happening, and they're real conversations as well, rather than new use cases that are emerging because of a new device type of thing. So it's almost like Google Assistant was creating new behaviors, new habits, and new mental models, whereas the contact center is having conversations anyway. So that seems to be a perfect place to start applying the technology, doesn't it?
That's actually a great point. Yeah, that's actually a great point. It's exactly the way we thought about it. Yeah, because there are channels that that the users are communicating, with the contact center that are already, exactly as you said, that are already pure voice, already over the phone, right, or over chat, and both of them, were perfect to actually, have like a fully conversational experience. And then also, like ultimately, the users are calling a contact center when they have a problem and they have, they want to solve a problem that they have, and so we figured out that that's actually another kind of point of the questions that you asked before. We very soon figured out that the large language models were not only good in understanding the user intent and what the user wants, but actually increasingly, and this is because of some techniques actually developed at Google, like chain of thoughts and reasoning react loops and so on, were actually increasingly good to break down problems in steps and reason two steps towards a solution, right? So that also allowed us to actually work a lot on these type of problems as well and kind of do the whole thing behind the scenes. So basically, we had like suddenly one technology that could do like all of these series of things for us, right? Maybe not, especially at the beginning, not the same model that was doing the whole thing, but a series of components all based on this new large language model technology, right? Like understand taking audio from the phone call, converting it to text, right? Then understanding the text, getting user intent, then basically trying to find a solution by breaking down, the problem in steps, and then figuring out, like the steps, and trying to resolving the steps one at a time, and then converting back to voice, all with this new technology, right? So that was like extremely, like basically a convergence of like technology and user problem that allowed us to solve a real user problem.
Yeah, absolutely. That's brilliant. When we had, as I mentioned, when we had Anthony Passamad on a number of years ago now, it was contact center AI was in its infancy, and we want to talk about search. We're definitely going to get to search, but before we get there, contact center AI was in its infancy. It was kind of pretty much recently announced. I don't think that the UJet partnership was in place at the moment. As I said, the Insights product wasn't available. Since then, a number of years ago, it's come on leaps and bounds. There'll be some people who are listening to this who are familiar with Dialogflow ES from the Google Assistant days and stuff like that. That obviously advanced to CX, which give us a lot more capabilities, a lot more ability to do things like dialogue management a lot more effectively and all that lot. It's obviously changed again because now it's got a whole load of generative AI capabilities. I wonder if you can just give us a summary for those that perhaps are not building with the Google Contact Center AI platform now. Give us a bit of a flavor about where this technology has ended up manifesting itself within the enterprise cloud AI features and within Contact Center AI.
Absolutely, yes. So basically, across of the steps that we kind of mentioned a bit already, but basically, there is like the converting speech to text, so that's kind of the first place where it manifests. But then inside Dialogflow, we actually added the ability to directly leverage generative AI to solve particular use cases. So Dialogflow, allows you to break the conversation in sub use cases, right? You implement the flows, right? That's kind of how it's called in Dialogflow CX. And then you can implement your flow as a normal Dialogflow CX graph, and that's like works still very beautifully for particular use cases that are kind of more prescribed for like many reasons, right? Like maybe because of the legal reasons, maybe because it's just, for instance, a payment, like a payment use case. You need to kind of add your credit card paid and whatever. Like that's something that like it works already really, really well with kind of standard technology. The completion rate are like super high, like 90+%, and they're kind of safe, right? So there's no need to change it, right? So basically, you can implement like certain parts of the experience with the standard Dialogflow, technology. But then also we added this new type of flow that we called playbooks. It was the first name. I don't actually know what is the current name of that product. But yeah, basically it's the ability to implement a flow by specifying instructions, specifying the tools that the flow, the agent can use, and then specifying kind of the functions that it can call, giving it access to the data stores that it can query, right? And then also like we developed a set of developer tools to enable developers to actually hill climb, like improve the quality of their agents when they develop them, right? So actually I think the implementation of agents in Dialogflow, like a no-code implementations of agents in Dialogflow was like one of the first on the market, really, and was like really implemented from the ground up to be actually useful. So not just to build like tools for playing around and do demos, but actually to build solutions to deploy in production that you actually are confident enough to give to your end users, right? And this is because like in Dialogflow, we integrated a set of developer tools, so you can implement your basically kind of specify your goal of that kind of part of the graph, that flow. You can give the instructions in a very kind of ordered, structured way, and then you can start testing it, right? And every time like you get like like one example where the chatbot is doing something different from what you want, you were able to to kind of fix it. Like we added tools where you can open up the conversation and then like add a comment to the model, right? And then like the model, like you were able to both fix the model answers, the tone, but then also like the tools that the model recognize that needs to be used in this moment, and the parameters to pass to these tools, right? So you can fix that, and then that data would then go back and be immediately available, because then we would retrieve semantically all similar examples from this example store, and then make them available in next time in real time, and then also later to kind of retrain the whole model, right? So I think like the integration, or like basically to answer your question, we started integrating increasingly Gen AI in Dialogflow, and do it in a way that actually works for the current state of technology, for the current world, and for the current requirements of customers who really want to mix and match the generative AI with the kind of the more predictable systems, like the normal kind of state machine flows.
Yeah. And I think that's the key, isn't it? Like a lot of the new breed of tools from a lot of the startups that you see out there, I think they tend to go too far down the Gen AI kind of path, which is great for, as you say, for experimentation and for doing demos and stuff like that. But when it comes to an enterprise using these tools for real use cases in the wild, sometimes actually the rule-based stuff works fine. I mean, chatbots, if a chatbot's well designed and well trained, it performs actually pretty decently. And generative AI and large language models help that become better. But I think that the goal of basically having those two things working together, I think, is really an effective one. And one of the things one of the things that's in Dialogflow, from what we've seen and the work we've done in Dialogflow, is there's also a data kind of store in there where you can upload data, you can stick it into a Google Cloud bucket, and you can have different types of data in there. You can even have like web URLs or whatever, and you can kind of manage that within Google Cloud. You can integrate that into Dialogflow, and then essentially at any point in time, you can determine whether or not you want to make that data store available for a large language model. So it kind of gets us into the search conversation, really, which is that many use cases that conversational AI applications have, even though they don't seem like it at the beginning, they're kind of a search use case. Like Dustin Coates, who many of the long-term followers of VUX World will know and remember. He was one of the co-hosts of the VUX World podcast from 2020 to 2022 or so. And one of the things he used to say, he works at Algolia on the search side, product management for Algolia Search. And he used to always say that Google Assistant, Amazon Alexa, these devices are first and foremost search-based devices. Because if you ask it to play a song, it has to go and retrieve the song from somewhere. If you ask it to find you a recipe, or you don't even say find a recipe, it's like, tell me a recipe for macaroni and cheese or whatever. That also is a search-based type of use case. And it's almost like with chatbots, you've definitely got more transactional flows that are more kind of utility-based. But there's a huge amount of value, and lots of the use cases that many organizations get started with is a kind of question and answer type of use case, isn't it? Which is fundamentally search. And a question gets asked, you need to understand what that question is. You need to go to the area where you'll find the answer and retrieve it. And so I'm curious about what your thought process is in terms of you going from Google Assistant to kind of cloud AI. Now you're heavily involved in the search AI side of things. How did that transition happen, and what specifically is the search AI component?
That's actually, it's the way that you put it is exactly how things happen. So a few points. Like one, you're totally right. In fact, on the Google Assistant, Alexa type of experiences, that they are mostly search. In fact, the first use case, like when we started Google Assistant, the first product we had in mind was conversational search, right? Like this is the first problem that we want to solve. This is where we saw the most value, and the rest came later, right? So you're totally right. That's the core. And then also, again, you're very right that the vast majority of the use cases in contact center as well can be reduced down to a search problem. In fact, the Dialogflow implement basically uses the search product that I'm leading now. It uses that to find everything that you said. Like you have your GCP bucket, you can upload your documents, you can add your intranet, your internet websites, or even connect to your external data systems that you have that have maybe structured data in them, or databases. Like, so basically you can connect all of your knowledge to, and give access to the chatbot, to generative AI, to get the right information for that knowledge. And a lot of use cases in contact center world, but in general, like even in other domains, right, can be really reduced to find the right information, and then get find the right information from like a vast source, kind of sources of data, and then find the right information about the actual user who is querying the system right now, and then answer based on the mixture of the two, right? So and this can be applied for like use cases like how do I fix my my internet is not working, like how do I fix it? Like also there you need to retrieve some documents on the web, most probably where the kind of the setup of how to solve these problems is described, and then kind of go through that and solve the problem. But also like like problems like that we are kind of very familiar on in the contact center space. When the users are calling and asking, like, why is my bill for September so high? Also there, you need to kind of retrieve the user data for September, and then basically kind of maybe mix it with some rules, of how the bills are composed, how the billing system works, and so on, that you also need to retrieve, and then you give all of that to the large language model, and then the large language model can answer those questions based on the data that is retrieved, right? So you're 100% right. And then this is also like how I transitioned then to lead search, because like we really figured out that the key pieces of the problems that we were solving, the most blockers that we were hitting, to really ship things in production were on the search side, exactly for the reasons you're saying. So there was like really a need to have like a huge investment in that area, to basically enable kind of search in cloud, right? To work really well with generative AI. So this is the team that I lead today.
Nice. And where is that? So we mentioned one area there of that search being manifested in Dialogflow. Is that the only place that search capability? Where else can you access that, and what other use cases are people using it for?
Oh, that's a great question. So no, the Dialogflow is just one of the use cases. Search as a product, it's called Vertex AI Search, right? It exists as a series of products. So the way that I think about search, so there is basically, there is like, or how customers think about search as well. Like they might need search to solve problems for their end users. So for example, if you are a retailer and you want to have a product search that allows your users to find products on your website, then you can use search, like our search product, to implement that type of system. So that's an external search, right? Or you can use, you can put like the search on your website, and it can be powered by basically the power of Google search, but it searches on your data. For example, companies like Reddit implement the search for the posts on their website using the cloud, the Vertex AI search. So that's the external search. Then there is the internal search, which is basically enabling customers to implement search for their employees, right? And the employees can be their knowledge workers, or it can be the agents answering calls, or like any other type of internal user, right? So that basically, like, you give, like in that case, usually search is done on like internal private data, right? So that basically it can surface the right data and kind of save time to increase productivity. And then there is the last piece, which is kind of search for developers. Basically, search is a platform, right? And we can enable like all of these use cases. We have one generic end-to-end search, right? That's kind of that's called Vertex AI Search, right? That does like a lot of the steps that modern generative search kind of products do. It does them like as a almost as a black box, like out of the box. Like you can set up like a great quality search in literally 5 minutes. You can just give it your URL. For example, for a website search, you can give it your URL, maybe some of your website, maybe some additional documents, and then like in a few minutes it kind of indexes everything, and it makes it gives you something that is that gives kind of huge quality out of the box, and then it gives you kind of tools where you can go and customize it to your use case, to your data. So that's like what we call Vertex AI Search. And then on top, we have implemented a series of vertical, specialized solutions that have additional functionality that are required by certain verticals. So we have retail search that allows customers to find their products. We have media search, so that customers can find can implement solutions to then end users to find videos, to find movies, or whatever is their use case. Health search, to kind of specialize on health search or healthcare data. And then internal search, we launch intranet search, where you can connect like all of your data and kind of find it. And then we have also like since we needed a lot of components to implement that, we also expose the main of these components also as kind of APIs for developers, so developers can use it to develop your other kind of custom applications that need just a piece. Maybe they just need a vector search, right? So for example, we have a vector search product that's basically the state of the art, kind of the Google quality type of infrastructure, but that can be used by you as a customer to kind of store your data in a vector search system so that you can find semantically find your information, right? And then another piece that I wanna kind of really highlight that we did is like things around grounding. That's like grounding. Like I don't know if that's like a concept. I don't know how clear it is. Maybe I should I don't know. Do you think I should explain what it means?
Maybe, yeah. I think a lot of the practitioners might be familiar, but it'd be worth explaining, yeah.
Yeah. So grounding basically means that large language models have certain limitations, right? For example, they obviously only know what they have been trained on, right? And they have been trained on a fixed set of data that's freezed after that, right? So the weights are freezed. So basically, if you want, to large language models, and the question requires some knowledge that was not available to them, they're not able to answer this question. So, for example, that includes like any real-time information, like sports information, weather, or any kind of type of real-time information. It also includes like any type of, private information that was not available to the models when they were trained, right? But also you can kind of make sure that when you're asking specific questions, you don't want the model to answer from its own knowledge that is like a mixture of like many things it learned from the web and from other sources, but you actually want it to answer for some authoritative set of sources. So basically, like grounding allows models to get access to either like data that otherwise it wouldn't have access to, or to more high quality, more accurate, more relevant data. So that's like the number one thing that grounding does. By doing that, you reduce hallucinations, which is a huge problem with large language models, right? So you actually are able to, to kind of give this piece of information, and then what we do, we actually tune. We have this what we call high fidelity mode. So we tune the model to be really to stay on point, to stay on the data that we give it, right, as input, and not like and try to like as much as possible like not add any details that are not verified by the sources that we give. So that's what we call factuality, and we really have the best results there. This is like what my team implemented in grounding. And then also it can give you the citation. So basically gives you the traceability, right? So that's something also that large language models are not great at, because it gives you an answer, but then you have no idea where is this answer coming from. It kind of learned it from like many sources, right? But now with grounding, you can actually see, what are the sources from where this information is coming from, and you can double check it. So, the users can go. And we launched, that in Vertex AI a studio. So you can use Gemini, and it's like super easy to use from the developer perspective. You just flip a bit, right? And then you can use grounding. And then basically like in the API response, you would get like the, you enable the model to call Google search behind the scenes, get the most relevant results. And then, we also give you the citations. Basically, we give you kind of from where the sources are coming from, right? So that's like, and the scores, like how confident is it for every piece. So that's like extremely valuable. There is another feature that we just announced, which is dynamic retrieval, we call it. So basically, like instead of like always turning on grounding, right, and always like every time searching the web for every query, like we introduced this new feature that only does it when necessary, right? So that's another super easy to use, just flag type of solution. And then the last thing I just want to mention is, in addition to Google search, we are also like working with a lot of third-party providers, so that that you can also use like very specific informations, like Moody's, for example, has like a whole series of super relative information on GDP from countries, or like many other types of information that you can leverage to get authoritative information for whatever is the use case you're trying to solve.
Nice, wicked. And would it be fair to say then that, given all these features that now exist in Google AI kind of search, would it be fair to say, not that I'm a search expert, but like search has gone through various kind of manifestations, hasn't it? From the early days of like keyword search and then moving it into sort of grammars, and then you had BERT and getting to more transformers. And now most of the kind of search applications that are being built now are pretty much, as you kind of alluded to, vector-based data storage, retrieval augmented generation applications kind of on top of it. Is it fair to say that that's kind of Google's sort of default standard now? Is that retrieval augmented generation type of architecture? Or do you still have recommendations for using some of the other search technologies from prior years?
Yeah, like actually, like the what we like Vertex AI Search, the product that I mentioned, implements all of these steps, right? It's so there's like a lot more happening. So one is first of all, to answer your questions like directly, so there is semantic search, and based on vector search is super important, increasingly important, right? But it's not the only thing. Like there's like many cases and applications where you do want to have more of a filtered like keyword type of search, right? Mm-hmm. So actually, combining the two is what is called hybrid search. Like this is what we offer as well. So it basically gives you the best of the two worlds, right? But then yes, to kind of like the steps of a modern search, there is many other aspects that come into it. There is, for example, one is kind of the recall of kind of getting the most relevant documents based on the semantic piece of information. But then there is a second step. How do you rank them now before passing them to the large language model, right? Yeah. That's like the ranking piece that it can be based on user preferences, user behavior. Like you as a customer, if you have your own user data, we allow you to basically kind of use that user data that you have about your users, and then you kind of add them to the Vertex AI Search, and that kind of is used by the ranking models to then further re-rank for relevancy relevancy before passing them to the next step, and using them in large language model to actually give you like a narrative, give you like a not only the blue links, if you say or in your whatever is your application you're building, but actually it allows you to then like give a full answer to the user that actually can guide the user to the whole journey, right, of discovering the information that you want.
Brilliant. I know we're right on time. One very quick question. AI has obviously got everybody's attention. It's still kind of relatively hyped, I would say. There's a lot of attention, a lot of kind of focus on it. Lots of use cases emerging. Where do you think it's heading? What do you think the kind of trends for people to watch out for over the next kind of 12 months are?
Yes. So I think definitely the models are keep improving. So the latest Google model, the Google Gemini 1.4 experimental, 1.5 Pro experimental, what is it, 0801, right, is now now it's on top of LMC's org, in the chatbot arena leadership board, and that model is really good, for example, in instruction following, right? So this is like and that means that it's like it's getting like really good in like the use cases like we just chatted about. So like I expect a lot of the use cases that people kind of hesitated a bit to solve with generative AI, because the model will still not follow well the instructions. So I think this is something that will kind of increasingly be solved. Right. So that's like one thing. Another huge trend obviously is so this is like kind of the smartness of the model, the ability to to follow instructions. The next one is multimodality. So that's a huge trend. You've seen it at Google I/O. Google Next was the project Astra, right? Where you can kind of in real time with your camera see the world and kind of converse with the models. So the models are getting super low latency, like the Gemini 1.5 Flash has this type of characteristic, like super fast. It can do kind of this real-time multimodal type of transformations and kind of processing. So that's like another huge kind of trend. And I think like the use cases that are kind of opening up, but these capabilities are are starting to get like beyond really the contact centers, or beyond even kind of the use cases for work, where I think there is like a lot of product market fit, right, still. Because like there is kind of like a user in the middle, right, a human in the middle. I think like the large language models are increasingly being able to solve complicated problems. So I see a lot of use in research, right, where you can actually use it to generate new hypotheses, to really understand deeply, the information, parse papers, and so on and so on. And like really solve like big problems for humanity as well. It's another kind of thing. Like if you see AlphaFold, right? Like there is the new version of AlphaFold that's extremely, that's gotten even better, and that's these type of technologies really are enabling us to generate new drugs us, the research industry, to generate new drugs much more efficiently. We have these floods prediction systems, for example, in India, right, where that kind of uses AI to predict based on on the various data, like where the floods will happen, like saving communities huge amount of lives and resources. So there's like, I think that's another trend that is kind of like where I see AI kind of increasingly helping solving bigger problems, because they are getting more capable and smarter. Multimodality, real-time usage, voice, video, definitely. So those are maybe some of the trends that I'm seeing right now.
Brilliant. Fantastic. Vlad, thank you so much for joining us. It's been an absolute pleasure, my friend. Always great to speak to somebody with your level of expertise. You definitely know your stuff, and I think it's great that, Google has always been up there, obviously on a global scale from the point of view of AI model development and creation and stuff like that, but also on the enterprise level, providing tools for people to be productive, get stuff done and all that kind of stuff. It's great to see the progress, and hopefully we can check in again at some point in the future and see where it's all at.
Absolutely. It has been an absolute pleasure, Kane, talking to you. Thank you so much for having me.
Thank you so much. And thank you all for tuning in. We will do this again as planned now that we're back on track with the old schedule. Next Thursday, same bat time, same bat channel.